Hello everyone. This is Dr. R. Sasikumar, Professor, Computer Science and Engineering Department from RMDEC Engineering College. Today we are going to learn about Booth's multiplication algorithm. The Booth multiplication algorithm gives a procedure for multiplying signed binary integers. Suppose if you want to multiply a negative number, then the most suitable algorithm is Booth multiplication algorithm. So it is based on the fact that string of zeros in the multiplier require no addition, but only shifting. And string of ones in the multiplier requires both operations. So if you multiply by number with the zero means what? No addition operation, we can do only shifting operation, but multiply by number one, then require both addition as well as a shifting operation. So performs addition and subtraction of the multiplicand based on the value of the multiplier bit, because we have a multiplicand and multiplier as our input. So the performance of addition and how many number of additions and subtraction required of the multiplicand means what? It depends upon the multiplier bit. The algorithm looks at two adjacent bits in the multiplier in order to decide the operation to be performed. So we have to consider the two adjacent bit of the multiplier. That two adjacent bit will be decided to perform the necessary operation. So the multiplier bits are considered from the least significant bit to the most significant bit. So we start from LSB to MSB, then that multiplier bit will be considered from right hand side to left hand side. So by default, a 0 will be considered at the right of the least significant bit of the multiplier. This is the flowchart of both multiplication algorithm. So the left hand side, the flowchart. So start and A equal to initially 0 and Q minus 1 also initially set with 0, and M is called what? A multiplicand, and Q is called what? A multiplier. So for example, 2 into 3 minus 3, right? So the 2 is called what? A multiplicand, and minus 3 is called what? A multiplier. So, and Q multiplier is stored into that register Q, and multiplicand is stored into the register 2. Then count equal to n number of bits. Then we have to consider the two adjacent bit of the multiplier, that is a Q0 and a Q minus 1. So two adjacent bit start from that LSB. Okay, if the Q0 and Q1 is equal to 1 1 or 0 0, then no addition or subtraction operation, only for shifting operation. That we have learned in that previous slide. So if the two adjacent bits are 1 1 or 0 0, no addition and no subtraction, only shifting. So that is an arithmetic shift, right? AQ Q minus 1, and decrement the count by 1. In case the two adjacent bits are 1 0, then we have to perform A equal to A minus M. Okay, if it is 0 1, then we have to perform A equal to A plus 1. So here the addition will be carried out, and here the subtraction will be carried out. So the repeated number of addition is nothing but what? Multiplication. So instead of multiplication, with the help of adder and subtractor, we can do multiplication operation. That is a concept of Booth multiplication, and the Booth multiplication algorithm is most suitable for negative number. Each and every time we have to check that whether the count is 0 or not. If it is equal to 0, then stop the process. Otherwise, you have to repeat the same process. So the step 1, the Q0 bit of the register Q and Q minus 1 examined. If the two bits are the same, that is a 1 1 or 0 0, then all of the bits of the AQ and Q1 registers are shifted to the right 1 bit. This shift is called what? Arithmetic shift right. So here this is called what? Arithmetic shift right. And if two bits are different, if 0 1, the multiplicand is added with register A. If 1 0, the multiplicand is subtracted from the register A. Then after that, step 2, perform right shift over register AQ and A minus 1, whether it is 1 0 or 0 1, then we have to perform the arithmetic shift right one time and decrement the count. So this is 32-bit register now. 32 times you have to perform the operations. So above 3 steps are repeated 32 times to obtain the product. So if the count is nothing but what n number of bits. So if the number of bit is 4 na, then four times you have to do that operation. If the number of bit is 8 na, 8 times the loop will be executed. If it is a maximum 32 means what 32 times repeated to obtain the product. And so here I have given one example, right? A fruit vendor purchases apple from wholesale market. In day one, he is selling each apple for 20 rupees. He gains a profit of 5 rupees each. In day two, he is selling an apple for 13 rupees. So the first day, he is selling each apple for 20 rupees and he gained the profit 5 rupees. The next day, he is selling an apple for 13 rupees. So find the total profit or loss for day one, day two. If he sells 30 apples in day one and 20 in day two. Assume yourself as a computer hardware designer and solve this step by step illustrating Booth's multiplication algorithm using 8-bit. Instead of 32-bit, here the question itself, they have mentioned that 8-bit. So we have to get the multiplicand and the multiplier. So what is our given value? The day one selling price is 20 rupees per apple. And the day one profit is what? Rupees 5 per apple. And the day two selling price is what? Rupees 13 per apple. So number of apples sold in day one, that's a number of apples sold in day one is 30 and day two is 20. So the number of apples sold in day one 30 and number of apples sold in day two is 20. This is the data given in that question itself. Now we have to find out the total profit or loss in day one, total profit or loss in day two. So here the solution. As per problem statement, vendor sells an apple in day one with a profit of rupees 5. So what is the actual price? Actual price of an apple is what? Rupees 20 minus 5, because we have to reduce that profit. Then you will get the actual price of an apple. So actual price of an apple is 20 minus 5. Here the 5 is called what? A profit. So if you reduce the profit from the actual price, then you will get the original price of the apple. So rupees 15. He sells 30 apples in a day one. So what is the profit or loss? So the total profit of day one, already we have mentioned that profit is 5 rupees. Now in particular day one, 30 apples he sold. So 30 into 5, that is the equation number 1. And the selling price of day two is rupees 13 per apple. So he sells an apple with the loss of rupees 2, because the actual price of the apple is what? 15. But the next day he sells an apple with a cost of rupees 13. So obviously 2 rupees will be lost. Okay. So he sells 20 apples in a day two. The total loss of day two is what? 20 into minus 2. So we got two equations. One is day one profit 30 into 5. The second day loss, that is a 20 into minus 2. Then we have to apply the Booth multiplication algorithm. So the Booth multiplication algorithm is most suitable for negative number, but it is possible to perform the positive multiplication also, but most suitable for negative number. So right now from the day one profit is 30 rupees into 5. So 30, the binary number is what? That 30 is a decimal number. The binary number with respect to 8-bit 00011110. I hope you understand that how to convert decimal to binary, right? So you convert a decimal into binary number, then you will get this number 00011110. So this is the way to convert decimal to binary. So you have to divide by again 2. So 7 2s are 14, remainder 1. Then again you have to divide by 2, 3 2s are 6, the remainder 1. Again you have to divide by 2, 1 2s are 2, the remainder 1. Now you have to write like this with respect to 8 bit. So 0, 1, 1, 1, again 1. The remaining 3 bits are 0 because in the question itself they have mentioned right with respect to 8 bits. So this is what 0, 0, 0, 1, 1, and 5. The same thing you have to do that operation. 5 is converted into binary number. This is the binary number of 5 with respect to 8 bits. Illustrating both multiplication algorithm, A is called what? Initial register. Q is a multiplier. Q minus 1 is the LSB bit. M is a multiplicand and steps. Okay, initial value A will be 0. All the 8 bits of A will be 0. And Q is a multiplier. What is called a multiplier? Pi is called a multiplier. So pi is called a multiplier. And the binary value of pi is nothing but what? 0, 0, 0, 0, 0, 1, 0, 1. And Q minus 1 initially set with 0. And M is nothing but what? Multiplicand. So this is called what? M. Multiplicand is nothing but what? 30. So the binary number of 30 is what? 0001, 1110. That is what initial value. Now we have to take the two adjacent bit of Q and Q minus 1. So here I have mentioned that one bracket, right? Q and Q minus 1, you start from LSB bit. So 1, 0. In that flow chart, already we know that if it is 1, 0 means what? We have to subtract A equal to A minus M. That is multiplicand is subtracted from the register A. Okay. So what is that register A? 0, 0, 0, 0, 0. That is what a register A. Here I have mentioned here. Okay. 0, 0, 0, 0, again 0, 0, 0, and 0. Okay. A minus M. What is M? M is 30. 0, 0, 0, 1, 1110. Okay. This is called what? M. Minus M means what? You have to take the 2's complement of the plus M. You will get a minus M. So how to take 2's complement? The simple step from left to right, okay, up to first one, you can write as it is. I am telling about how to take the 2's complement of plus M. So the above one, this is called what? Plus M. Okay, this is called what? Plus M. Okay, 0001, 1110. Now I am going to take the 2's complement of plus M. Up to first one, you can write as it is. So 0, 1. If 1 is appeared, then the rest of the number will be complement. If 1 means 0. Here 1, so 0. Here 1, so 0. And here 0, so 1. Here also 1 and 1. So what is called minus M means what? 1110, 0010. So this is called what? Minus M. Minus M. Okay. And this one is called what? Minus M. 1110, 001. Because in the flow chart, right, if two adjacent bits are 1, 0 means what? M will be subtracted from A. So M is nothing but what? A multiplicand, but you have to take the 2's complement of M. That is called what? Minus M. Now you perform the addition. That is A plus 2's complement of M. That is nothing but what? Subtraction. Okay. So now you perform the addition operation. 0 plus 0, 0, right? Sorry. This is A, this one is A, and this one is minus M. Okay, now you perform the operation. 0 plus 0, 0, 1 plus 0, 1, 0 plus 0, 0, 0 plus 0, 0, 0 plus 0, 0, and again 111. So that is the answer. 1110, 0010. Okay, that is A equal to A minus 1. Then after that, what is that step? You have to do that arithmetic shift right. AQ A minus 1. So how to shift right means what? That listen carefully, right? That MSB bit of A, that MSB bit of A is retained. So how to retain that? This is what A equal to A minus M result. Now we have to do that arithmetic shift right. Okay. So you have to retain that bit as it is. 1 will be retained as it is. Again, that will be shifted right. Okay, again, this will be shifted right. Again, this will be shifted right. And 0 will be shifted right. Again, 0 will be shifted right. Then 0 will be shifted right. 1 will be shifted here. And 0 will be shifted here. This 0 will come 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 here. Again, 0 will come here. 1 will move on to here. And 0 will come here. And this 1 will come here. This is the way to shift right one time. Okay, then final result is what? 4 ones 0 0 0 1, 4 0 0 0 1 0 1 again. This is what iteration 1. Then next iteration, because here the number of bit is 8, so we have to do that 8 different type of iteration. So now you take that 0 1. So what is 0 1? If it is 0 1 means what? A equal to a plus m, not minus m. So a multiplicand will be added with a, then the result is stored into a. What is the recent value of a? This is the recent value of a. So 4 ones 0001, that is the recent value of a. Then a equal to a plus m. What is m? 0001 110. So now you can perform that 111 41, then 0 0 0 1, again m value 0 0 0 1 1 1 1 0. Now you perform addition. So this is a and this one is a multiplicand. Okay, now you perform addition 1 1 1 1 1 plus 1 0, carry 1 1 plus 1 0, carry 1, again 1 plus 1 0, carry 1, 1 plus 1 0, carry 1, that carry will be discarded. The final result is what? 0 0 0 0 4 ones. So 0 0 0 0 4 ones. This is nothing but what? A equal to a plus m. Again, you have to do that arithmetic operation, shift operation. You have to retain that MSB bit as it is, then shift. So you have to shift one by one. Likewise, that data will be, this is iteration 2. Again, 1 0. So 1 0 means what? You have to do that a equal to a minus m AR. So likewise, you have to do that all 8 iterations. Then finally, you will get the result. That result will be available in that a q. Okay, this is the final result. Okay, and you convert into decimal value, that is a 40 decimal. So date to sorry, likewise you have to do that operations, right? AQ, then finally you have to do that multiplication 30 into 5, you will get 150. That is so day one profit is what? 30 into 5, 150. So that is the answer. That answer is available in that slide. Last AQ which contains the final result. So you convert this binary into decimal, you will get 150. So 30 into 5 obviously will get 150. That is the answer is correct. This is the way to ensure whether the result is correct or not. So the day one profit is 150. So in this problem, we have a two questions. One is a day one profit. Another one is a day two loss. Okay. Day one profit is what? 30 into 5. Day two loss is what? 30 into, sorry, 20 into minus 2. So we have to do that 20 into minus 2 and this 20 and minus 2. So the decimal number of 20, sorry, binary number of 20 is, this is the binary number of 20 and the 2, everything will be represented in terms of 8 bit. So the plus 2, the binary number is what? 0 0 0 0 0 0 1 0. This is plus 2. Minus 2, you have to take a 2's complement of plus 2, you will get minus 2. I already told how to take 2's complement of plus number means what? Up to first one, you can write as it is. So 0, 1. The remaining number, you take complement. 0 means 1, 0 means 1, here 1, here 1, here also 1, and here also 1. The final result. 4 ones, 1110. So the minus 2 is nothing but what? 4 ones, 1110. Then you apply the both multiplication algorithm. A is initially set to 8 bits or 0. Q is nothing but what? A multiplier. Here multiplier, what is called the multiplier? minus 2 is multiplier. The binary value of minus 2 is what? This one. And q minus 1 initially 0. And m is multiplicand. What is called m? 20. So 20 is the multiplicand initial value. Then you have to take the two adjacent bit of q and q minus 1. 0, 0. 0, 0 means what? No addition, no subtraction. Only perform the shift right. So shift right means what? You can retain this MSB bit as it is. Then the 0 will be shifted here. This 0 will be shifted here. This 0 will be shifted here. This 0 will be shifted here. Likewise, you can shift. Okay. And that 1 will be shifted. Okay, sorry, 0 will be shifted here. Okay, this is the way to shift all. That is the first iteration. Again, you have to take the another q and q minus 1, 1, 0. If it is 1, 0 means what? Then the multiplier will be, a multiplicand will be subtracted from a. So a equal to a minus m operation. Minus m means what? Already the value is negative. Minus m means what? You have to take minus of minus m. So minus of minus m, which is nothing but what? Plus m. So plus m. So already the input is minus 2. So minus 2 of minus 2, which is nothing but what? Plus 2. You know the binary value of plus 2 already 0, 0, 0, 0, 0, 0, 1, 0. So a equal to a minus m. Then you have to calculate it here and arithmetic shift right. That is the iteration 2. Then again you take the two adjacent bit 1, 1. 1, 1 means what? No addition subtractions are required. Then you have to shift right only shift right, and then that MSB will be retained here. Okay, then 1 will be shifted to likewise. So likewise, you have to shift all the number. Then again 1, 1, no addition subtraction is required. Only for arithmetic shift right. So MSB bit retained here and shift. So likewise, you have to shift all the bit. Then again 1, 1. So likewise, you have to check all. And finally, what you will get 20 into minus 2 minus 40. So what is the answer you got? You know, that is the answer for minus 40. Okay, you convert this number into decimal number, you will get minus 40. Okay. This answer is not correct means what? Then you have to take the 2's complement of that number. Okay, if you take the 2's complement of number, that is a 2's complement of AQ, then you will get minus 40. That is a way to ensure whether the result is correct or not. Okay, the final result, if it is not equal to minus 40, then this is negative multiplication. So you have to take a 2's complement of last value. So after taking 2's complement, then you will get minus 40. So the day 2 loss is what? Rupees 40. So final conclusion, the day 1 profit is 150. The day 2 loss is 40. So this is the way to perform the both multiplication. Once again, I tell that the both multiplication is most suitable for negative multiplication. I hope you understand this concept. Thank you.